So in this video we're going to look at ratio and proportion. What does it mean when a question says to us something is directly proportional to something else? Well, I think proportion is something we understand fairly intuitively, so I'm going to start with that. If I line up these pieces of paper, I think we'd all agree that they're in proportion to one another. But what do we mean exactly? What we mean, I think, is that the sides here, so these two different sides, are always in the same proportion. So the ratio, in fact, is going to be the same each time. And one interesting thing that we can profit from understanding, we can see actually visually, is that these corners are lining up nicely. So if I draw a dotted line joining up these corners, you can see that more clearly. That's a straight line. So it's a straight line relationship. And this is a very important idea that we're going to work with now. If I draw a set of axes, 1 to 10, and I think about the ratio, it's a much simpler ratio than my pieces of paper here, which are probably quite complex. I'm just going to use 2 to 3. 2 to 3. Let's label these X and Y. So my X value is 2 and my Y is 3. I'm going to plot 2 to 3 on this graph. Okay, and I should get the same as I've got here, a straight line. Let's have a look. So 2 along would be to here, and 3 up would be to here. Okay, and now if I scale up, just as I did with my pieces of paper, if I double it, let's say, I'll end up with 4 to 6. So 4 along, and this time 6 up. Maybe I should label my axes. So this would be 5. This would be 5. Okay, so good to put a few values on so you can easily work with any axes. But here we've got 4 to 6, so I'm now going to scale up again so that I end up with 2 times 3 this time, 6, and 3 times 3 is 9. So 6 to 9, so I'm going to plot on 6 to 9. Now, if I join this together, again, just like with my sheets of paper, to get that straight line, I can use what I know about straight line equations to give me an idea that I can work with to solve problems. So, excuse me, I know that for any straight line on a graph like this, the formula, the standard form for a linear equation, is y equals some constant k. Well, that's the slope, it's the rise over run. I could use m, I could use any letter. K is conventional. So y equals k times x plus whatever the y-intercept is, whatever x equals when this line intercepts the y-axis. Well, actually, that's going to be 0. Because you can see with any of these ratios, if I draw this back, just actually let's use the piece of paper, draw this line back, it should go through that corner there. Let's just see if it does. Okay, so it goes exactly through that corner there. In the same way, when I draw this back, that's going to go exactly into the origin. So when y is 0, x is 0. When x is 0, y is 0. So that intercept, which is part of the standard equation here, is 0. So I can just erase that. And I end up with a very simple equation that you will learn and memorize, very useful. When what we're saying is if two numbers, as in this ratio here, are directly proportional to one another, then we can say when x, in other words, is directly proportional, we use this symbol like that, when x is directly proportional to y, so if we've got a directly proportional relationship between x and y, it's not a kind of random, it's you could say perfectly correlated relationship, directly proportional, then y will equal kx. So y will equal some constant k times x. Now, why is that a really useful idea? Well, if we're talking about the slope in this case, 2 to 3, we can easily calculate that. That's going to be rise over run. So if I take any 2 points here, draw my little triangle here, then I've got 3 rising and 2 in the run. So 3 over 2, which is 1.5. Okay, so in this situation with my 2 to 3 ratio, k is 1.5. So if I was given any other ratio, and it was in the same proportion, okay, if it was just a scaled up ratio, I could say, all right, let's have 100. Let's have 100. So when x is 100. Okay, so now I know my x, I know my k, so y must equal 1.5 times 100. So y, in other words, is 1, move the decimal point, 150. So I can now write my, it's not y, is it? It's x. Well, should work the same. Let's have a look. No, you see, now if we get it round the wrong way, look what's happened here. So very important that we've made this mistake. We've now got 150 to 100. Instead of 2 to 3, it should be 100 to 150. So let's go back and do that again. Okay, so what was I given? I was given that y was 100. Okay, so let's have another go. Okay, so y is 100, so I substitute my 100 in here. 1.5 times x. Now, if 100 equals 1.5 times x, then x must equal, we'll divide both sides by 1.5, so I've got 100 divided by 1.5 now. Okay, so I'm going to double that to get 200 divided by 3, and 3 into 20, well, 3 into 20 gives me 6 and 2 remainder. So again, 6 and 2 remainder, and I'll end up with 66.6 recurring. So in other words, 66 and 2/3. So let's write it in fractional form. Okay, so that's corrected our mistake there, and it's got us to an interesting scaled up ratio when y is 100, x is 66 and 2/3. So this idea that if x is directly proportional to y, and y of course then is directly proportional to x, then we can write y equals some scalar k times x. This is really useful for solving this kind of proportional problem. Often they say in the problem one thing is directly proportional to another, so find this missing value. Let's have a look at an example of that. So let's get rid of our pieces of paper and come up with an example problem. Let's say we had then, let's say we're given that when x is 5, okay, when x is 5, y is 3. So again, what then is y? Let's say when x is 35. Okay, so we can use our idea here. We've got y, if they're directly proportional, so directly proportional, let's just work this out, gives us enough room. So if directly proportional, or I could have just written if x is directly proportional to y, but if directly proportional, then y must equal some constant k times x. And you can get a mark just for writing this down and understanding this principle. Okay, so let's have a look at how we would substitute in, first of all, this ratio. So y is 3, so this time I'm going to be careful to put in the right value. So y is 3. So therefore 3 equals k times x is 5. So times 5. Or it might be easier to put them around the other way and say 5k. So 3 equals 5k. Therefore k is, divide both sides by 5 and we get 3/5. So k is 3/5. Now then I can substitute into the right hand side. So again we've got y equals kx. So we've got y equals 3/5 times 35. And if you work that out, so you've got 3 times 35, that's 105, divided by 5. 5 into 10 is 2, and 5 into 5 is 1, so 21. So we should get y equals 21. Now, hopefully that's pretty clear and you understand how that method works. There is a sort of simpler way of doing it, and it's a good way of checking if we got this correct, if this is correct. So we're going to check now if we got the right answer simply by using what we know about ratios. So what we're going to do is simplify both the left hand side and the right hand side, and that will give us our check. Now the left hand side is already simplified. Okay, you can't reduce this down, you can't scale this down to get a simpler value. So on the left hand side we have the same, 5/3. But here we want to get this to be as simple as this. In other words, we want to get these values to be the same. So if we divide again by 5 like this, not by 5, whoops. How do we get this to be 5? We divide by 7. So divide by both sides by 7. Then 35 divided by 7 will give us this 5. So we've got 5 to y. We could write this 1/7 y. That's going to be a bit more intuitive. Okay, so 1/7 y. Okay. So that's simplified both sides in a sense, but it's given us the chance of equating the y values. So we've got a 7th y. Now we know that the x values are the same, the y values must be the same, so we can now write that 1/7 y equals 3. Okay? So y, if I multiply both sides by 7, I get 3 times 7. In other words, I get 21. So this must be correct. So just a way of checking that our method, using the insight that we get from linear equations, our method actually works nicely. And so 2 different ways of doing it, doing the same thing, gets the same answer, gives us that confidence that we must have the right answer. Okay, so let's work on 1 or 2 more problems just to get this properly established. What can we do now? Let's try something like, so if we are given that 27, when x is 27, y equals, what can we say? Let's say 81. Keep the numbers fairly simple, even though we're scaling them up a bit. Then what about when x is 2, let's say? What will y equal? Okay, well, if they're directly proportional, they're part of the same system, in other words, then we can use this y equals k. So y equals k times x when they're directly proportional. So, in other words, with the left-hand side here, the first ratio here, y is 81. K we don't know yet. X is 27. So 27k. 7. Okay. So k has got to be, divide both sides by 27, you get 81 divided by 27, k must equal 3. Okay, so therefore k equals 3. And now that we know that k equals 3, we can again use our y equals k times x, so that we get now y, which is our unknown, equals 3 times 2, which is 6. So nice and easy. That using that formula, the y equals kx, hopefully gives us the right result. I was going to tick it, but we don't know yet. Let's do our check. Okay, so again, if we simplify both sides, or simplify this side to start with, 27 to 81, well, obviously 27 goes into both 27 and 81, so I can simplify this down now to 1 to 81 divided by 27, 1 to 3 then. And in this case, I've got 2 to y. So actually what I might do, because you can play around with these things, is I might just scale this up. Okay, so instead of 1 to 3, I'm going to write down 2 to 6. So 2 to 6. Okay, so 2 to 6 equals 2 to y. Therefore, y must equal, so we can equate these two values, y must equal 6. X are both 2, so y equals 6. Which is the result that we had here. Okay, so let's do one more. Okay, so problem C. Now what I'm going to do here is make this a little bit more challenging. I'm just stalling here so I can think of some numbers. Yes, so if I think of 784, because I know how that will simplify nicely, and 105. These are numbers we used in a previous video. So we're given that when x is 784, so not something we'd maybe want to draw, y is 105, then what about where, well, let's say we don't know the x, but we do know the y. So when y is, let's make this even trickier, 0.3. Okay, so let's see if our method works when we've got numbers like this. Okay, so again, we've got y equals some constant k times x, and we're going to find k first. Okay, we use the left-hand values, so we've got 105 equals, what's x? 784 times x. So we've got x equals 105 divided by 784. Now I'm going to use my calculator for this. I think we could just divide by 7 and get the, well, let's not use the calculator actually for the moment, because we'll get a decimal answer. I'm going to keep it as a fraction. So 7 into 105 is 1 carry 3, so 15. And 7, which is our highest common factor, is going to be 1, 1, carry 1, 2. Okay, so I'm going to resist the temptation to make this a decimal at the moment. So x, our unknown factor, should be 15 over 112 when y is 0.3, so that would be 3/10. Let's find the decimal actually and see what that is. Okay, so I thought it would be a long one, so it's 0.133 and on it goes. So you could use that, but you can see it's not going to be accurate. So we'd prefer to keep this in its exact form. Not x, sorry, it should be k. There we go. So 784 times k. So this is what k is. So this is our scalar. Okay, so now we just use the right hand idea, and we use this scalar to plug into our ratio on the right hand side here. So we've got now again y. Well, we know what y is already in this problem. So we'll immediately put in 0.3. So 0.3 equals our scalar, so 15 divided by 112 times x, so 15x divided by 112. So x equals 112 times 0.3. divided by 15. Okay, so just rearranging there to get a value for x. Now if I work that out on my calculator, I get 2.24. But before I happily move on to the next question, I'm going to give this a check. So let's see if I can check it using what we understand about ratios. Okay, so we know we can simplify this. We know the highest common factor of 784 and 105 is 7. So let's now reduce this down to a much simpler ratio. So 7 into, well, we've already done it over here. So 7 into 784, we get 100, 112. Okay, so 112 to 105 divided by 7 is 15. So, okay, easier numbers, not very easy numbers, but at least they're smaller. And now we've got x. Now what I'm going to do here, in fact, is I'm going to scale up immediately to get rid of this decimal point. So I'm going to write 10x, in fact. So 10x to 3. So 10 times 0.3 is 3. Okay, but I still haven't got any equivalents going on here, so I'm going to now change it again. So it must be that 112 to 15 equals, I want this to be 15 now, so I multiply both of the sides of this ratio by 5. So I end up with 50x to 3 times 5, 15. Okay, so now from here I can equate the x values. So I've got 50x, so therefore 50x equals this value here, 112. So x equals 112 divided by 50. Well, that, even without a calculator I can do this, is 224 divided by 100, which is 2.24. So good. I'm going to say that this calculation then was correct. Okay, finally, there is another technique that we can use, which is changing ratios to fractions. Now, I've already said in a previous video that this can be fraught with danger, so you need to know what you're doing here. However, it's a technique that can speed you up. It's another good way of checking, and it's not unlike what we did here. In fact, it's the same idea, really. What we did here was we used a check which was simply to compare the x and y values so that we ended up with a simple formula, 1/7 y equals 3. And that works really nicely. It's a very quick check, as you'll see. A lot of people would want to do this directly, so they would want to take 5 to 3 and write it as a fraction. So 35 to y. And it works. You can rearrange this, you can cross multiply. So if you understand what you're doing by cross multiplying, you're multiplying both sides by y and multiplying both sides by 3. That means you're going to get 5y on the left hand side, and you're going to get 3 times 35, which is 105 on the right. So now divide both sides by 5 and you get the value for y very, very quickly and very, very simply. However, there is a danger, because what we've done here is we've assumed then that 3, get rid of that. Okay, we've assumed that 3 and y here are whole values. So in other words, they're the whole of a fraction, whereas in fact we were dealing with part-to-part ratios. Okay, so that isn't going to be a problem here. It's as if the equation in fact doesn't understand that and doesn't bother with that. It just simply sorts itself out. It's going to be the same if it's a ratio or a fraction using this equating methods. So it actually works out fine. But there are other situations where, we've seen as we've seen in previous videos, where if you assume that a ratio, a part-to-part ratio, is a fraction, in other words, part-to-whole ratio, then you're going to run into problems. You're going to get the wrong values. You're going to get the wrong answer. So I want you to think maybe about using this cautiously, I guess. Another way of thinking about this, which would be even better than this, would be to think, let's use a different colour. Think about, well, what if I didn't have y in the denominator? That might make my rearranging a bit better. So if I had y to 3, so instead of 35 to y and 5 to 3, what about y to 35 and 3 to 5? So let's see if that works out. Y to 35 equal to 3 to 5. Make sure you get your numbers around the right way. Okay, again, cross multiplying, you get 5y equals 105, so y equals 21. So that works. And another way of thinking about it, which is just as good, just as quick, is if we think about going right across from here to here. So now y to 3 must be the same, which is basically the idea that we were using here, in fact. Y to 3 must be the same as 35 to 5. So y to 3, converting to a fraction, y to 3 equals 35 to 5. Now it's going to work out just the same as this. 5y, cross multiplying, 5y equals 3 times 35, which is 105. So again, we get y equals 21. We get the right answer. So having looked at it as a method that's good for checking, I would still say, it's very important to have this concept. Y, if x is directly proportional to y, then y must equal some constant k times x. Quickly find the constant and then substitute back in, and you will get your y value. Y equals 21. Now, although it takes a little bit longer, this is the correct way, I think, to think through the process and understand exactly what's going on. And that way you're not going to get in a muddle. You're not going to be relying on formulae and methods, algorithms, rather than understanding what's actually happening. And that's important for situations like this. So what if we had, well, we had 0 to 0, and let's have 3 to 0, and let's have 0 to 3. So here's 2 examples, all of them with zeros in them. Now, when we're dealing with ratios like this, if we think about it in terms of ratios, just ordinary part-to-part ratios, there's no problem in thinking about 0 to 0. We've got no, let's think of something, let's think of green paint. Okay, so we've got no green paint mixing with no green paint, so we've got no paint at all, so we haven't got any green at all. Here we've got 3 red litres, let's say, of paint mixing with no litres of green. What's the resultant colour going to be? It's going to be just red because there's no green mixed in. No problem at all. Here we've got 3 litres of green paint, 0 litres of green paint, so no green paint rather, and we've got 3 litres of blue. Okay, so again, just blue. No problem in any of these things, but if we suddenly convert these to fractions, we are going to run into difficulties. Let's have a think. So if we have 0 to 0, but this now has become a part-whole relationship, so there are 0 parts of no whole. Well, what would that mean? You could say that 0 divided by 0 is 1. Okay, because anything divided by itself, like 2 divided by 2, is 1, as we know. So 0 divided by 0, I guess, could be thought of as 1. On the other hand, anything multiplied by 0 is 0. So you could also say 0 divided by 0, so 0 of these is 0. So what we've got here is a contradiction. You can't in maths have 2 possibilities, 2 possible answers, and so we say this is undefined. And you'll get an error message in your calculator if you attempt it. Let's try this one. 3 to 0. If this now becomes the whole, so it's 3 parts of nothing. 3 parts of nothing. So again, that doesn't make sense. It's meaningless. You'll get an error message and it's undefined. So it makes perfect sense as a ratio. It makes no sense. It can't be allowed. It can't be used as a fraction. Finally, what about this one? 0 to 3. But now we assume it's a fraction, so 0 thirds. Well, that's perfectly okay. It's the same as 0 times 1/3, and so it's no thirds, which is 0. However, it means something different to the 0 green and the 3 blue, which is a part-to-part relationship. Okay, so this time it means 0 of the third portion. Okay, 0 thirds. It means a different thing. So be careful when you're changing ratios to fractions. Use it, but use it knowingly, and just keep being aware of the difference between part-to-part ratios and part-to-whole fractions.